Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the details about the DC motor. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the details about the stepper motor. Let's start our today's topic. What is stepper motor? The stepper motor is a brushless DC motor with a fixed number of steps that make a full rotation. A standard motor will have step angle of 1.8 degrees with 200 steps per revolution. That means we can say that the stepper motor is also a DC motor. That means it works on the direct current supply. Okay, and it does not rotate continuously or smoothly, while it rotates in number of discrete steps. Okay, I hope you all understand the basic details about the stepper motor. That is, the stepper motor is rotate in discrete various number of steps. Okay, now let's see the working principle of the stepper motor. As all with electric motors, stepper motors have a stationary part called as stator and a moving part called as the rotor. In this cross section, we can see here this part is a stator and this part is a rotor. Okay, the stator is stationary part, that means it does not move, while the rotor is the rotating part. It rotates according to the magnetic field produced in the stator and rotor. On the stator, there are teeth on which coils are wired, while the rotor is either a permanent magnet or variable reluctance iron core. Here, on the rotor, there are the teeth are present. On these teeth, the coils are wired. That means these are the coils. And when we energize or we supply the coil, then a magnetic field is produced according to the supply. Okay, the figure shows a drawing representation the section of the motor where the rotor is variable reluctance iron core. Now let's see the working principle of the stepper motor. By energizing one or more stator phases, magnetic field is generated by the current flowing in the coil and the rotor aligns with this field. That means if we energize these coils, then a magnetic field is produced, and depending upon this magnetic field, the rotor rotates its position. That means in this direction. If the magnetic field is produced in these coils, then it rotates in this direction. That means in clockwise direction, or if we give the sequence reverse, then it can move in anti-clockwise direction also. By supplying different phases in the sequence, the rotor can be rotated by a specific amount to reach the desired final position. Okay, I hope you understand the basic simple principle of stepper motor. Let's see once again. When we energize the coils of the stator, then a magnetic field is produced and the rotor aligns with this magnetic field. Depending upon the sequence, we can rotate the motor in clockwise direction or in anti-clockwise direction. Okay, this is the simple working principle of stepper motor. Here, the figure shows the representation of the working principle. Let's see once again. At the beginning, coil A is energized and the rotor is aligned with the magnetic field produced. That means at the start, the coil A is energized and the magnetic field is produced and the rotor is aligned with this magnetic field like shown here. Okay, when coil B is energized, that means when coil B is energized, then the rotor rotates clockwise by 60 degree to align with new magnetic field. That means when coil B is energized, it rotates through 60 degree. The same happens when coil C is energized, it again rotates with 60 degree. Okay, I hope you all understand the simple working of the stepper motor. Now let's see the animation here, in which we can see that the stator has the four teeth. That means only two coils. This is suppose A and this is B. If this is positive A, then this is negative A, and like this. Depending upon the sequence, depending upon this sequence, we can rotate the motor in clockwise or in anti-clockwise direction. Here the motor rotates in clockwise direction. Okay, that means when we give the different supply like this 0101, then the magnetic field is produced and this rotor rotates according to the magnetic field produced in the stator. I hope you all understand the simple working of the stepper motor. We can also rotate the motor in anti-clockwise direction by changing the sequence here. Okay, now let's see the construction of the stepper motor. Depending on the type of rotor, there are mainly three types of stepper motor: permanent magnet rotor, variable reluctance rotor, and hybrid rotor. Depending on the type of stator, there are mainly two types: two-phase stepper motor and three-phase stepper motor. Let's see the details about the permanent magnet rotor. In this permanent magnet rotor, the rotor is made up of the permanent magnet. The rotor is a permanent magnet that aligns with the magnetic field generated by the stator circuit. That means in the circuit, in this stator, this coils produces the magnetic field, and according to this magnetic field, this rotor is aligns itself. The solution guarantees a good torque and also a detent torque. This means the motor will resist, even if not very strongly, to a change of position regardless of whether the coil is energized or not. The drawback of this solution is that it has lower speed and lower resolution compared to other types. The step angle of this motor are 1.8, 7.5, 15, 30, 34, and 90 degrees. Now let's see the details about variable reluctance rotor. The rotor is made up of the iron core and has a specific shape that allows to align with the magnetic field. We can see here that it has the specific shape. With this solution, it is easier to reach a higher speed and resolution, but the torque it develops is often lower and it has no retained torque. It gives the step angle of 7.5 or 15 degrees. Now let's see the last type, the hybrid rotor. In this rotor, we can see here that the rotor is specially constructed. The hybrid means it has both the permanent magnet and variable reluctance type rotor. This kind of rotor has specific construction and it is a hybrid between permanent magnet and variable reluctance versions. The rotor has two caps with alternating teeth and is magnetized axially. The step angle of this motor are 0.9 or 1.8 degrees. This configuration allows the motor to have the advantages of both the permanent magnet and variable reluctance version, especially high resolution, speed, and torque. This higher performance requires more complex construction, hence, the cost is high. These are the types of the stepper motor depending upon the types of rotor. Now, let's see the advantages of stepper motor. The low cost for control achieved, high torque at startup and low speeds, ruggedness, simplicity of construction. It can operate in an open loop control system. It has low maintenance, less likely to stall or slip. It will work in any environment. It can be used in robotic in a wide scale, and it has the high reliability feature. Now let's see some basic applications of stepper motor. That the stepper motor is used for precise positioning with a motor like hard disk drives, robotics, telescopes, and some toys. It can be used in industrial machines. Stepper motors are used in automotive gauge and machine tooling automated production equipments. It also used in security, that means in new surveillance products for security industry. It can be used in medical. Stepper motors are used inside a medical scanner, sampler, and also found inside digital dental photography. These are the basic things about the stepper motor. I hope you all understand all of it. Thank you.